Hello everyone. Let us attempt to solve for x in this exponential problem. Given 4 raised to power x plus 16 raised to power x is equal to 64 raised to power x. If you rewrite the equation 4 raised to power x plus 16 raised to power x equals 64 raised to power x, one would immediately see that 4 raised to power x tend to be common to all terms of the equation. So I will write the bigger terms, which is 16 and 64, in terms of 4 raised to power whatever the power is. So this becomes 4 raised to power x plus 16 is 4 raised to power 2, then raised to power x, and 64 is 4 raised to power 3, then raised to power x. This gives us 4 to the power of x plus, if I open up this bracket, 4 raised to power 2x here, and here 4 raised to power 3x here. Now I can divide through by 4 raised to power x because it seems to be common to all terms. And doing that and applying basic law of indices, this gets rid of this. You have 1 left here. And by law of indices, this becomes minus x. And this goes away. This becomes minus x as well. So that we have 1 plus 4 raised to power 2x minus x is simply x, then is equal to 4 raised to power 3x minus x is 2x. If I rearrange this new equation, I'm going to have 4 raised to power 2x minus 4 raised to power x minus 1 is equal to 0. Indirectly, we have a quadratic equation, but I can make a simple substitution and say let 4 raised to power x be p, for instance. So I'm going to replace here 4 raised to power 2x can be written as 4 raised to power x raised to power 2, which now means p raised to power 2. Therefore, I have 4 now p raised to power 2 minus p minus 1 is equal to 0. Can we solve this quadratic equation? It is not factorizable as we are looking at it. We are going to apply the quadratic formula to solve for p. The quadratic formula is given by p is equal to, given that the coefficients of p squared, p are a and b respectively, and the 1 here stands for the letter c, then I'm going to say minus b plus or minus the square root of b squared minus 4ac, then all divided by 2a. Let's identify the terms. A here is 1 and b here is negative 1. C here is also negative 1. If we put those values into this new equation here, then our p is going to be minus 1, then plus or minus the square root of b squared is negative 1 squared, then minus 4 into 1 into negative 1, then all divided by 2 into 1. Let's tidy this up. P is equal to, so here we have 1 plus or minus 1 plus 4, then over 2 times 1 here is 2. So the value for P is 1 plus or minus the square root of 5 over 2. Remember, our substitution here says 4 raised to power x is p. So let's go and say this is now 4 raised to power x. Therefore, 4 raised to power x is equal to 1 plus or minus the square root of 5 over 2. So how do we solve for x in this problem? We can go ahead and change the fraction on the right to decimal, or we can just leave it like that. So our answer is in the exact form. Take the logarithm to base 4 of both sides. This will give us log 4 raised to power x base 4 is equal to log to base 4 of 1 plus or minus the square root of 5 over 2. So this gives us x log 4 base 4 is equal to log to base 4 of 1 plus or minus the square root of 5 over 2. All of this becomes 1, and our x is simply log to base 4 of 1 plus or minus the square root of 5 over 2. You can go ahead and press the exact value of this logarithm on the right hand side to get the decimal equivalent of x, but as far as we are concerned, this is the final solution to this problem. Thank you so much for watching. Hit that like button, subscribe to my channel, and I'll see you in my next video.